Let's hear from Mostefai Mohammed Amine, .NET architect, leading us into the next discussion. In this talk, he will present a decoupled CMS using the headless recipe, MySQL database, and Azure-based shell. He will show how to prepare the environment using ASP.NET Aspire.
Thank you. Good morning, everyone. I'm really happy to be here, and thanks for accepting my talk here. So, Amine. I am a certified Azure architect and developer, so I worked a lot with .NET since 10 to 15 years, different domains, banking, finance, etc. And today I'll be talking about Aspire. So, Aspire is something that was released with .NET 9, and something that just makes developers' life much better. So, who worked with Aspire, please? Who can tell me? What do you think of it?
I don't know enough, but from what I heard, it's mostly from Sebastian, but it's quite exciting in terms of the orchestration of an environment.
Okay.
But
you know that I work on Aspire?
Yes.
You know that? You know that I work?
I don't. And tell me, let me share my honest opinion. It's the biggest innovation in .NET Core since .NET Core itself. So I really like it. So for the ones who don't know Aspire, so I will do the first half of my presentation. I will show how Aspire works. My second half, because we are in an orchard presentation, I will show you how we leverage Aspire to make our experience with orchard much better. I'm exposing something we did in a real use case. So what is dev-time orchestration? So let's imagine this scenario. So I'm developing an application with a backend, which is based on ASP.NET Web API. I'm talking, of course, about the .NET ecosystem. A backend composed of web APIs. Frontend built with Blazor and a database. Let's say PostgreSQL. So I have to set up my environment, yes or not? Of course, I need my IDE, and I need 2 instances of IDE to test the client and backend, or have multiple runs with Visual Studio or whatever. I have to install somehow the database to make it work, and I have to fix all the issues related to the connectivity between the backend and the database. I have also to have some other tools to show what's inside the database. For example, if I'm using MySQL, I need something like PHP to see if my data is correctly written. So a lot of things to do, and sometimes it takes a lot of time and effort. So instead of focusing on solving the problems, the developers focus on solving the dependencies problems. And that's what Aspire is built for. It's built to make the developer life much better, but it's much beyond this, and you'll see this. So with Aspire, we focus on code rather than the environment. It handles by itself dependencies. It's based on Docker containers, and it's fully based on open telemetry. So one other thing when I'm building complex systems is when something goes wrong, I have to troubleshoot every component of the system. The backend, it can be an error on the front end, and it's multiple places to see and multiple ID to debug with. But with open telemetry, I have a single place where I see everything. So Aspire.NET was introduced with .NET 9, and it's, let's say, am I correct if I say sub-framework, Sebastian? So it's a tool, technology to handle all these dependencies, this application, etc. So what is Aspire.NET composed of? So I'll show everything in the IDE later, but it's composed of an application that is the host. So the host is just a web app that will orchestrate the other web applications. It has also another component called the service defaults. So what is the service default? It's a special project that we add to the solution that is shared among all the other components. And then we'll manage resources. And what do we mean by resources? The resource can be a project, it can be the backend, it can be the front end. It can also be the database. It can be a cloud resource like, I don't know, storage. It can be cache. And we'll see all of this in action. And just to let you know, it's evolving. So I think we have something like 3 or 4 major versions since the version 1. And every time we have a lot of exciting new things in Aspire. So enough talking, I will start with a demo, very quick demo to see how it works. So I will create an empty solution with my IDE. I will call. Please let me know if you want to change to my team. Do you see? Is it okay? So I have created an empty solution. So the next step, I will create 2 components. I will create the backend and I will create the front end. So the backend, I will just create. I will go to web. I will create a web API project. I will call it Harvest Backend. Cool, it has been created. Of course, with this famous endpoint weather forecast. I will create the front end. This time, I will create a Blazor web app. I will call it Harvest Client. So far I haven't done anything fancy. So I have a solution that includes 2 sub-projects, one for the client, one the backend. Now, the interesting thing begin. So the first thing I will add, so it's the same in Visual Studio. You'll see the templates. On the left, you see the Aspire project. The first thing I need to create is the host. So I will name the application Harvest Host. The other thing, I will create another Aspire project, which is the service defaults. I will call it Harvest Service Defaults. So, what is the host? If I open the program in the host, it's very similar to web application, and actually it is a web application, except that it starts with distributed application, create builder, instead of the traditional builder. And we'll see how it's used. And what is the service default? It's just a class library that has some code that should be shared among all the other projects. I will show you. But before I begin, it's very important. I have to update my dependencies, because when it starts, it creates the Aspire project with the first version of Aspire. I need to update to use the latest version of Aspire. You can see, for example, the app host is on 9.00, but the current version is 9.52, and there are a lot of differences. I will upgrade. You can also notice that it uses some other. No, this is not Aspire related. This one and this service did go. And that's it. So the first thing, I will try to run the host. So among the application, you can see that the Harvest host is listed as any other web application. I will run it. You see, it's the first look of Aspire, but it is completely empty. If you see the resources list, I have nothing, because I haven't referenced any project yet. So remember please the concept of resource. A resource can be an application or can be something else, a database or cloud service. For now, I don't have anything. So my next step is I will add resources to my project, and to be precise, to my host project. So for this, I have to reference the backend and the client. Let's start with the backend. So I will call it backend, and you see that the AI automatically proposes something. I called it harvest backend. I will call it just backend. And let's run this again. What happened? I shouldn't have upgraded the... I will downgrade it to version, let's say 9. Okay. You can see now that the host started with 1 resources, and this is the backend. And what does it offer? It offers a lot of things. So we can see, for example, the output of the application directly here. We can see the traces of the application directly here, and much more. But let's do something else. So for now, I've added only 1 dependency, which is the backend. The other dependency is the client. The same way, I have to add the harvest client, and the name should be client. And something very important to do is for my components to reference, if you remember, the service default. So for the backend, I will reference the harvest service default. I'll tell you why after. And same thing for the client. I will go to the Bootstrapper just after creating the application. I have to do this. You see, it added add service defaults, which binds the application to the OpenTelemetry and adds some other services like discoverability of the services. I have to do the same in the client. I did it for the client in the backend. You see, it started also my Blazor application. Let's go to the orchestrator. And you can see that I have 2 resources now. I have the backend and I have the frontend. But I don't have any orchestration yet. So I will add some orchestration between the 2 applications. I go back to the host. So I created the backend and I created the frontend. But I want the frontend to reference the backend and to wait for the backend, which means when I need the service discoverability, so the client will recognize directly the backend without any change, and also it waits until the backend starts. So I will add this. Wait for, I will specify backend. And I have with a reference to the backend. I go back to my orchestrator, and you can see it's too quick to be visible now, but in the graph, for example, you can see that I have a dependency between my client application and my backend, because my client depends on the backend. How does it work? So in the client, I will call the weather forecast. So I will add just API consumer class. I will inject the HTTP client. I'll add a string method. Let's see, get data. I'll put this inside the try catch. And here I will call the client. Do you remember the endpoint? Is if I go back to the backend, it is using the minimal API. I will just use this. And I will use this. Okay, and then I'll just return the response. Okay. Last thing to do, and this is very important, I have to declare my service in the dependency injection. And here, I add an HTTP client. It's API consumer, but please pay attention for the base URL, base address. Is backend. I'm using service discoverability to use the alias of the application instead of the real address of the application. Let's hope this works. If it doesn't, I have one that works. I'll just inject this in my home page. I will override the uninitialized async. I will create a variable okay, and then this one should just call did I call the method? Get data. And then I'll just display this in a paragraph. Let's try this out. You see the response. What happened? So using the discoverability feature, and it's not only the discoverability, it's also, for example, the resilience, etc. It has a lot of other features. So I could make my front end call the backend. One last thing before going to the next topic. So let's imagine that my backend uses a database, which is the case in most of the situations. So Aspire comes with a lot of services that it supports for databases, for cloud providers, etc., etc. For example, I want to use PostgreSQL. The only thing that I have to do, I go to the host, and I will reference. So most of this start with aspire.hosting. I think I'm missing the S. Okay, let's say PostgreSQL. I will add it to my, pay attention, I have to add it to the host. Okay. Now, I'm doing a mistake here. I should add it to the host, not the backend. So I will add it to the host. I will go back to my application. The first thing I have to add the server PostgreSQL. So I will call it just PostgreSQL. And look what it does. It creates a service, not only the service, it adds also the client tools, the PG admin, to make my life really happy, because I wasn't before. Next thing to do is I will create a database. I will call it RSDB. Last thing, I have a dependency between what? Between my backend and with my database. So I will make, to be sure that everything works, I will wait until the database is created, and I also reference the database. So I will say, wait for DB, and with the reference, you see what does it mean to DB. And let's start. That's pretty done. But do you see? My architecture is becoming a bit more complex. And I'm waiting for the resources to start. You can remember that my client waits for my backend, and my backend waits for the database. But I don't have any dependency towards pgadmin. That's why it didn't start yet. But it waited for pgadmin to start to show everything in the orchestrator. I will go back to the graph, and you'll see the different dependencies between the components. One last thing I will show, I will click on the pgadmin. I will open the servers, the databases, and you see that my database has been created. Why? Because it is leveraging containers. You can see that it has created the PostgreSQL container. It has also created the pgadmin, and it did the job to link both. One last thing to call out. I go back to the orchestrator. You see my backend. I click on the three dots, view details. Can you see the connection strings? Automatically, with reference to the database, passes the connection string with a randomly generated stored password to the application. So I don't bother with this also. I'll go back to my presentation. So I will present very quickly. So the first use case without orchard. So I have this architecture. So I have a backend that is offering APIs, and the APIs calls the backend application to get some data, and if the data is successfully collected, it puts them in the cache. So next time you call the API with the same key, it will get the information from the cache instead of the database. So I will just close this solution. Yes.
Did you show the tutorial logs when the client called the backend?
Yes, I will show it now. I'll make sure that I don't have any containers, okay? Anyway, it doesn't want to. So I have my first API demo. I will close the other windows just for clarity. So let me show you what's happening in the host. Yes, I forgot also something. I have also an endpoint in my web API that calls a cloud component, which is the queue, that puts a message in the queue. So if you see the code, so far something that you know already, I created a database server, a database. Now I'm creating an Azure storage. What does it do? It just creates an emulator. So, and then in the storage, I will create the queue service. I can also create the blob service. You will see it in the Orchard demo, because Orchard I will use the blobs to store my shells and my data protection files. Then I create the backend that waits for now the PostgreSQL and the queues, and I create the cache. And this time the cache is not referenced by the backend, but by the client, because it's Blazor server, not Blazor client. So it's also server side. So it uses the Redis cache to cache the data when it comes from backend. You see, I have a lot of resources starting. So the first one is just ping call. I'm calling the backend, and the backend is returning an information. The second thing, I created a background job in the backend. Where is it? That creates some countries. Okay? So I will just call with the country ID. It's France. And I call again, it's France. But there is a big difference. The first time it went to the backend, to the database. The second time, it got it from Redis. The last thing I will do, I'll just push a message to the queue. So let's see to the structured level. And this is very important. So this shows all the semantic logs that are emitted by the different applications. And it's an excellent way to troubleshoot if I have any problems. And the other interesting thing is this, the trace. It shows me the interactions between everything, every component within this system. So the interaction between the backend and the client, the interaction between the client and their cache, and the interaction between the database, etc., etc. And it's very, very helpful, especially for performance. I hope I'm not too much over time. I'll just show the graph, which becomes much, much more complex because we have a lot of dependencies. So now we are in Orchard conference. Let's talk about Orchard and how this made my life easier, our life easier. So I was working on this project. So this is the company website based on Blazor, decoupled with Orchard. And we had some issues with auto setup, with migration, how to test it every time we have to drop the database to do some stupid things. And why don't we just leverage something that exists, which is Aspire? So let me show you a use case that is inspired by a true situation. So we have the client app that fetches categories, but the category information is split between two stores. So we have the metadata, the name, the ID, etc. They are stored in the database. And we have the content, so the description of the category, which is a rich text, is stored in Orchard as a content system. So what does the backend application? First, it will call the database. Then it will call the Orchard to fetch the content from Orchard, prepare a response that is composed of the composition of both. What does the client, which is Blazor server? It will put the response in the cache. Next time, it won't fetch the two sources. And the architecture is similar to this. So we have a backend that is connected to SQL. And then the client application calls the backend calls the different sources, so the database. No, the client calls the two, and then it puts the information in the cache. Let's see this in action. I will stop the API demo. I will go to Orchard demo. Just to be clear, I will remove everything. And let me show you the most important part for our talk today, which is the host. So what does the host? First, it creates the MySQL service. You see, I am using a different database server now, not PostgreSQL, with also PHP MyAdmin to see my databases. Now, instead of one, I'm creating two databases. I'm creating the application database, I'm creating the content database. Then, you see in my project, I have two backends. I have the web API backends that fetches the metadata from the database, and I have the content backend, which fetches the content from Orchard. So I have the first backend, which has reference to what? To the AppDB. And I have also the storage. Why do I use storage? Especially blobs. Because I have something that is similar to production. Because in production we use Azure to store the shells files, the media files, also the data protection files. So you see, I create the storage service, and what I need now is the blobs. So I create the blob service. What you can see also, I'm creating at the same time 3 blob containers. One for the shell, one for the media, one for the DP, and one for the media cache. One last thing I haven't talked about is I can also create secrets in the orchestrator. And this time I'm creating the admin password, which I will pass to Orchard to use as administrator password. Let me show you something in the content application. I have also migrations. I'm using migration. So I created a recipe to create some content types, and I'm also injecting some content items to Orchard to use them for the demo, to see how it works. So I will try to run. Sorry, I'm a bit over time. Very sorry. You can see that it is starting. A lot of components have to start. I'm waiting for the 2 databases. Okay, now my client app is run. I have created a category called AI. I will call it get category. So the first part, the ID and the name is coming from the database. The text is coming from what? From Orchard. So the HTML is just coming from Orchard. I will show you the Orchard subadmin. I will use the password that is passed by the host. Which is this one. And you can see that I tested successfully my recipe, my auto setup, and everything works like a charm. And I can repeat this infinitely because it runs every time as a new container run. And I think that was it. Sorry, I was a bit over time.
Thank you very much.
Any questions?
Questions, comments?
Just a very small one. In the very beginning, you hard coded the backend URL.
Yes.
At one point. Can you show how to do it in a way that it will be just backend when you're doing it development time, and it will be I don't know, listening to every URL when it's deployed?
No, this is just for the demo. But because in reality, this will be put in app settings dot development, because it is specific to development. But for the others, we pass this through the app settings. So we put the real URL.
Oh, but yeah, I understood that this is just for
Yes.
demo. But okay, then in a real application, then you put it into an app settings file, so
Yes.
it doesn't come from the host.
Yes, exactly.
Okay.
Exactly. Because the host, as you can see, it can override the settings by passing environment variables. You can see a small problem here, small example, sorry. So for the content APIs, the host is overriding the ORCHARD password. You see it here somewhere. It's not visible. I'm trying to make it bigger. Anyway, so you can see that the host is passing the admin password to the application, to the content application, that overrides the one that is an app setting, if any. So it works like this. Does it answer the question?
Yeah, thank you.
Other question?
Basically, it's a continuation of what Zoltan was asking. For local development, if we wanted to have a persistent DB, how would that be set up?
This is a very good question. Behind the scenes, so Aspire leverages local containers. So we can use containers with volumes, which means that my database will be put in volume instead of the local container files. So the next time the same container runs, it will retrieve the same data and you won't lose it.
And do we have to set that?
You call the method with persistent.
Exactly. If I go back to the
There's a method for
There was
the
a follow-up.
So if we go back to the database builder, I can see that it offers with data volume, and we have also the container lifetime. With container, which is, I don't remember this lifetime. Yes, container lifetime. What is it, Sebastian?
Yeah, call something like with container lifetime. And there is an enum that says persistent or with.
Yes. I don't know why it,
That's the method.
I think it's at the database level, not at the service level.
No, it's a service. It should be the service.
Should be the service. So why I'm not
Because it's
seeing
the
it.
container itself that is persistent, and the databases, there are many inside it.
Okay, anyway. So there is the container lifetime with what? For now I'm using the default, which means the container will be destroyed when I stop the application. But if you want the data to be persistent, you can use volume and you can use it the lifetime, persisted lifetime.
Okay, thank you.
Hi. How difficult would it be to change this demo to use managed identities rather than passwords?
Can you?
I implemented it, so I can answer. you do nothing. It just works.
Okay, that makes sense.
So when you don't set a password, all these
The default
things,
is managed
the
identities.
default, if you do add, like MySQL, there is no, yeah, there is, but if you do, like there is a with Postgres here, that to add Postgres, but there is also a component that is Azure Postgres, so you do add Azure Postgres, and by default, it's passwordless. So the connection string won't get the password, and then the client will have it. So all these services, if there is an Azure instance, the managed entity will be supporting this.
And I forgot because I was focusing on the dev lifetime, but Aspire also prepares the deployment. So a word about it, Sebastian.
So in 5 hours, you can deploy.
In 5 hours, Aspire 13 is released, and then you can do Aspire deploy, and everything you see here will be deployed as a Docker Compose file on Azure App Service, on Azure containers, wherever you want.
If you work with AWS, it will generate the CloudFormation files. If you work with the Azure, it will generate the bicep files. So if you work with Kubernetes, it will generate the YML files. So with the Docker deploy, it will do this very quickly.
Okay, thank you very much.